Hi, I'm Jim Burnham. We're constantly talking about how you need to memorize the polyatomic ions. So today I want to talk about how to easily accomplish that. And we're going to group them together in big clumps that make a lot of sense. So let's look at the polyatomics that we're supposed to memorize. Here are 25 of the polyatomics. It comes from page 147 in your textbook. And we want to commit to memory, or at least be able to recognize when we see them, these 25 polyatomics. Now, the first thing we want to think about is, and we know that we can predict the ions depending on what group they come in. For example, all of these metals here make +1 ions. All of these make +2 ions. This group makes a +3 ion. This makes either +4 or -4. These are all -3, -2, -1, and these are zeros. So starting with that, I think that can be somewhat helpful. For example, if you know that chloride is a -1, it's a halogen, it's in this group here, and all these are -1s. Well, we know the charge on a chloride. Remember, this isn't chlorine, right? The element is chlorine, but the moment it becomes an ion, it's chloride. We change the ending to an "ide." And this has a -1 charge. Well, look at all of these. All of these chloride polys, they all have the same charge, -1, -1, -1, and -1. They all have the same charge as the chloride. So that's huge. So you know that anytime you see a chloride, and chloride is going to be either something with an oxygen, so it's either going to be an ite or an ate. Remember, if you ever see ite or ate, it means a poly with an oxygen. And so this is a poly made with chlorine. And so we have 4 of them in a row here, but they're all -1, just like the controlling chloride ion here. So you're going to get a 5-for-1 special here because they're all -1. And now all you have to remember is we're going from a hypo, which means less than chloride, to chlorite, to chlorate. Chlorate means more than chloride, and perchlorate means many. So you just have to remember we're going to start with, if we only had 2, it'd be chlorite and chlorate. But if we have more than that, then we're going to have 1 less than chlorite, or hypochlorite, and 1 more than chlorate, or perchlorate. Once you have the pattern down for the chloride, you also have the bromides, because it has the same thing. They're all -1, and it's hypobromite, bromite, bromate, perbromate. You also have the iodides. You have iodide and hypoiodide, iodide, iodate, periodate. All right, now let's look at sulfide. Sulfide comes from this group here. This is the oxygen group. This is the -2 group. So oxygen and sulfur are both going to be -2 in their ionic form. So here's our -2 ion, not sulfur, but sulfide. And the 2 polys we're going to build out of this are also -2. So here's sulfite. Ite means less than 8, so this is going to be the lesser, the 3, and the 8 is going to be the greater, the 4. Notice we only have 2, so we don't have hyposulfite and persulfate, like we would in the, remember, in the chlorides. We have that chloride, chlorate, and then lower than chlorite and then higher than chlorate. So what we have here is, again, it's an ite. It's built out of sulfur and oxygen, and it has the same charge. The poly has the same charge as the naked ion, and it's a -2. And you just have to remember, one of these is a 3 and one of these is a 4. And the lower is the sulfite and the higher is the sulfate. Now, since this has a double negative charge, you can imagine we can add a hydrogen to both of these. If we add one to the sulfite, it becomes hydrogen sulfite. Okay, so it's just adding a hydrogen to this sulfite group. We can also add a hydrogen to the sulfate group, and we have hydrogen sulfate. So again, you have 4 polys, all with this expected -2 charge, and then these drop down a charge because we're adding a positive ion, a hydrogen, to each. And so that's going to reduce that -2 to a -1. So here is hydrogen sulfate. What would happen if we added 1 more hydrogen to this? Then it would become H2SO4, and that would become an acid, and we would call that sulfuric acid. So just imagine, we just start from here, we add an H, and then we add another H. And that takes me from sulfate to hydrogen sulfate to sulfuric acid. All right, let's look at the next one, phosphide. Phosphide is in this -3 group. You have nitrite, phosphide, arsenide. They're all -3. So helpfully, the polys, the ites, the polys made with phosphide and oxygen are a -3. So if you can just remember where phosphide comes from, what group it's in, all of the polys built out of phosphorus are also -3. So here we have phosphite and phosphate. Again, this is very similar to the sulfite and the sulfate. So if you can remember if you remember the 3-4 combo there, you should be able to remember the 3-4 combo here. The difference here is that all of these are -3s, whereas when we were back here, these were all -2s. And again, just like the sulfites and the sulfates, we can add a hydrogen to each of these. This becomes hydrogen phosphate, right? We're just adding hydrogen to the phosphate. Here we're adding a hydrogen to the phosphate. We can also add a double hydrogen, so a dihydrogen to the phosphate. And that reduces, so one hydrogen reduces the 3 charge to a -2. 2 hydrogens reduces the -3 charge to a -1. What would happen if we had one more hydrogen? It would make it an acid, and we would get phosphoric acid. How about oxygen? Oxygen, again, like the sulfur, is in the -2 group. So here's one way to think about hydroxide. Hydroxide is this O2 with an H plus added to it, and that H plus is going to reduce this -2 charge to a -1. So hydroxide is simply the oxide plus a hydrogen, making it hydroxide, making it a -1. So again, if you can remember the -2 on oxygen, you should be able to remember that this drops to a -1 because we've added a +1. What would adding one more H do? It would make it water, which does act as an acid. So that's kind of interesting. But we don't call water an acid, but I mean, it does function as an acid. Okay, nitrogen, N3. So we would expect this, like the phosphides, we would expect the polys made out of this to be a -3. But, so this is nitrite. It's not nitrogen anymore, it's nitrite because it's the ion. But it doesn't follow the phosphide rules. And the polys made out of these are not -3s like you'd expect. They're just -1s. You have to remember that these are different. This is the one time where the rule will let you down. So mostly the rules will help you when you look at the individual ion, but in this case it will mislead you. So you have to just remember, no, the nitrates and nitrites, okay, they're 2s and 3s. Remember the other, for sulfates there were 3s and 4s, and phosphates there were 3s and 4s. So these are lower, and this charge is lower than expected. It's not a 3-, it's just a 1-. What would you get if you add an H to nitrate? You would wipe out this charge, it would be neutral, and it would be an acid. It would be nitric acid. All right, when it comes to carbon, again, carbon doesn't usually form ions, but if it did, it would form, it can under certain circumstances, it would form either a +4 or a -4. So carbon dioxide is, of course, a neutral molecule. All molecules are neutral. So this won't help us, but if you think about carbon dioxide, which is not an ion, and you add an oxygen to it, if you shove another oxygen into this, then you would go from this negative versus this neutral molecule, because you're adding an extra oxygen, which is -2, you make this whole thing a -2. So you can think about carbonate, the polyatomic carbonate, as being a carbon dioxide plus another oxygen, oxide ion added to it, if that helps. Otherwise, you just have to brute memorize this one, CO3, -2. But because there's a -2 charge, you can add a hydrogen to it, that becomes hydrogen carbonate, and if you added another hydrogen to it, it would become neutral, it would become an acid. It would be what? It would be carbonic acid. Okay, silicone. Again, silicone, like carbon, would form +4 or -4. The oxide is called silicide. It makes a dioxide, just like carbon dioxide, known as silicone dioxide. This has a 0 charge, and this is not an ion. So a little asterisk here, it's not an ion. But if you thought about silicate as an oxygen being shoved into the silicone dioxide, it would give it a -2 charge, which is what silicate does have. So if you can remember those, you can get carbonate and silicate as CO3 with a -2 charge or an SiO3 with a -2 charge. Okay, here's a couple of tougher ones. There's only one positive poly that we generally talk about, and that is ammonium. Ammonium is NH4 with a +1 charge. You can think of it as an N3, a nitride with a -3, combined with 4 H's. And think about those 4 positive H's will counterbalance all 3 of these and leave you with 1 net charge, a +1 net charge. So that to me is a helpful way to remember ammonium, the -3 nitride, +4 H's, leaving you a net +1. Chromium is a little tougher here. So chromium, this is chromium 6 plus oxygen. So chromium 6 means this is a +6 ion. So if you add 4 -2's, that becomes a -8. -8 plus 6 leaves you a -2. So this is chromate. This is your chromium 6 added together with a -8, giving you a -2. And then think of dichromate as just shoving 2 of those together, shoving 2 chromates together. So if you have a chromium 6, if you have 2 chromium 6's, that's a +12, and then you have 7 oxygen, that's a -14. +12, -14 leaves you a -2. So both chromate and dichromate have a -2, and it's one CO4 and the other's Cr2O7. But it's helpful for me to remember that it's chromium 6 and you're just shoving oxygens to counterbalance. So that leaves you with 4 that you just have to straight up brute memorize. This one's called oxalate. The way I try to remember this is that this looks like it's effectively 2 carbon dioxides shoved together. And it gives you a -2. Even though these are neutral, but when you shove 2 of them together, this isn't how you make it, but that's how I think about it. So instead of a carbon and 2 oxygen, you have 2 carbons and 4 oxygen, and it leaves you a -2. Just oxalate. That one you just have to straight memorize. Cn -1 is cyanide. Cyanide is a deadly poison. So, we can talk about cyanide capsules and cyanide pills and whatever. So, to me, this is interesting. Cyanide, Cn negative. You just have to memorize that, but it's fairly simple. And somewhat unusual looking, Cn -1. All right, this is known as acetate, and acetate is a toughie. So for me, I use a mnemonic built out of the letters for acetate. So here's how I do it. I look at the C and I see there's 2 C's, and I see there's an A and an A. So the 2 C's are represented by the 2 A's. And it also has 2 T's at the end, and that represents the 2 O's at the end. And so I need something 3 in the middle. Well, I have an E and an E, and if you just drew a line across this C, that would become an E2. So E, 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 that's the hydrogens in the middle. So I think of this acetate as 2, 3, 2, right? 2 carbon represented by the A's, 3 hydrogen represented by the E's, the 3 E's, one of them is a C converted, and the 2 T's representing the oxygen. So C2H3O2, 2, 3, 2, acetate. Again, that's a toughie. You're just going to have to straight memorize that one. And the last one here is permanganate. And permanganate is built out of manganese. So manganese comes in a bunch of different ions, and one of them is known as manganate 7. So why do I say that? Because if you think of this as a +7 counterbalanced by 4 -2's, then of course you'd have a -1. +7 - 8 is a -1. So it's called permanganate. Why permanganate? Because manganese makes a bunch of different ions, and the per ion that's the 7. I think it makes like a 5 and a 6 and a 7. So anyway, this is the one that's more. This is the extra, the higher one. But whatever the case, you have this thing, this is manganese, and this is the one that's called permanganate as a -1 because it's a manganate 7 counterbalanced by a -8. Anyway, that reduces the burden to just really those 4, I think, are the tough ones. So rather than having 25 things to brute memorize, you've kind of reduced the field down to 4. Okay, so that takes care of your polys. So you look at this, you go, what is this? Oh yeah, this is phosphate, right? Here's phosphate, then we add 1 hydrogen to it, becomes hydrogen phosphate, drops into the -2. We add another hydrogen, it drops into the -1, dihydrogen phosphate. If we added another one, making it neutral, it would become phosphoric acid. All right? So again, here's our oxalate, that's our CO2s, 2 CO2s shoved together. Here's our acetate, 232. Here's sulfite, add a hydrogen, hydrogen sulfite. Here's a sulfate, add a hydrogen sulfate. Here's a carbonate, add a hydrogen. Here's hydrogen carbonate, and so on. Okay, so now you know the acids as well, because the acids are simply the polys with enough added hydrogens to make them neutral. So, for example, here's chloride. We can add hydrogen to this and make it neutral. How much hydrogen do we need? Just 1. And that gives us hydrochloric acid, HCl. This is a neutral molecule. Here we go. We have sulfate, a -2. We can add how much hydrogen? We can add 2 hydrogens to it to make it neutral. That gives us H2SO4, which is sulfuric acid. So remember our sulfites and sulfates, we got SO3, -2, SO4, -2. We add hydrogen to each, hydrogen sulfate. And now this becomes sulfuric acid because it's no longer an ion, right? It no longer has a charge. Its original -2 charge has been fully balanced by 2 hydrogens. So now it's a neutral acid called sulfuric acid. I say electrically neutral. Okay, we have a nitrate, which doesn't follow the rule. It's a -1, although you'd expect it to be more. How many hydrogens do we need? We need 1 hydrogen to balance it out. So HNO3 gives us nitric acid. And here's acetate, has a -1. How much hydrogen do we need to balance it out? Just 1, and that gives us acetic acid. How about this one? If we have a phosphate, how many do we need? How many hydrogens do we need to balance it out? We need 3. So H3PO4 gives us our neutral acid, phosphoric acid. Remember, this is our group, and remember, we can build them up one by one. And as long as they maintain a charge, they're one of our ions. So here's phosphate, -3. Here's adding 1 hydrogen phosphate, adding another one, dihydrogen phosphate, adding 3 total makes it phosphoric acid. It's not trihydrogen phosphate at this point because, look, there's no charge. Now it's no longer an ion. It's no longer a polyatomic ion. It has been converted into an acid. Okay, one last one, I think. Carbonate has a -2, so it would take 2 hydrogens to convert it to carbonic acid. And remember, just like that, we can add, before we get to carbonic acid, where it's fully hydrogenated, we have this partial step where we just have 1 hydrogen added to the carbonate, which makes it hydrogen carbonate. Okay, so just a quick review. Here are your 6 acids built out of your polys. Right, this is made out of a chloride. You add a hydrogen, hydrochloric acid. You have a sulfate, add 2 hydrogens, you get sulfuric acid. You have a nitrate, add 1, get nitric. Acetate, add 1, get acetic acid. Phosphate, add 3, get phosphoric acid. Carbonate, add 2, carbonic acid. Right, this is just a compound naming flowchart. There'll probably be another video we'll do on how to name things. But basically, if it has an H, you want to think acid. If it doesn't have an H, then you want to see if it doesn't end in an ite or an ate, then you think poly. If it doesn't have a poly, then it's binary. And if it ends in ide, then you know it's a binary, and it's either going to be a molecular binary or it's going to be an ionic binary. And you can just work your way through this. So that's the naming. But the key thing is that those 25 polys are not as hard as they seem. So you got this. All right, thanks for your attention. Take care.